Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find graphical limits. All right, before we get started with the problems, let's go over the strategy that we're going to be using to find our graphical directional limits. Case number one is the case where you're approaching a point, okay? And that point could be defined or not. When we're talking about the defined point, it's a closed circle, okay? A point that's not defined is an open circle. So if you're approaching a point, whether defined or not, the limit is normally the y-coordinate of that point that you're approaching. So just simply trace the points to the y-axis, and then whatever the y-coordinate is, that's going to be your limit. Case two, you could be approaching a vertical asymptote, okay? In that case, when you're approaching the vertical asymptote, your limit is either going to be plus or minus infinity. If you're heading towards the upward direction as you approach that vertical asymptote, your limit will be infinity. If you're heading downwards, then your limit will be negative infinity. The final case is oscillating while you're approaching a boundary x value. So some functions exhibit an oscillating behavior as they approach a particular x value. So if it keeps oscillating up and down graphically, in that case, the function is not approaching a specific y value. So in that case, the limit does not exist when you're oscillating as you approach a particular x boundary. Okay, so let's consider this graph right here. Y is equal to f of x. And we're going to be finding the following limits. So instructions, let's define the limits graphically. Okay, question number one. The first set of problems will be centered around x equals -6, okay? All right, so question number one, let's say we're to find a limit as x approaches -6 from the left side of the function. So for this particular problem, what case are we dealing with? Are we approaching a point defined or not, a vertical asymptote, or are we approaching an oscillating, or is the function oscillating as we're approaching that value? So in this case, -6 is right here. Right here, -6 is a point. So we're actually approaching a point. Okay, so as we approach -6 from the left side in that direction, what is the y-coordinate of the point that we're approaching? The y-coordinate is -7. Okay. Question two, what if we're to find a limit as x approaches -6 from the right direction? In this case, from the right, we are approaching a point. We're approaching the same point, which is defined, okay? So here, we have case one, so we just simply read off the y value that the function is approaching as x gets arbitrarily close to -6. And the answer here is also -7, okay? Question three, what is the value of the function evaluated at -6? Now, these are two different things. The limit means you're approaching that x value. F of -6 means you are already there. So when you're at the x value of -6, what is the y-coordinate? What is the output value? That's what the question is asking. And we can clearly see that the output value is also -7. Okay? So the answer to number 3 is -7. Next question, question 4. What is a double-sided limit here? What is the limit as x approaches -6 of the function? Well, the double-sided limit is a combination of the left and right-hand limit if they are approaching exactly the same value. If the left and right-hand limits are approaching different values, then the double-sided limit does not exist, okay? Because which one are you going to pick, the left or the right? It doesn't make sense. In this case, the left and right-hand limits are both approaching -7. So guess what? The double-sided limit is exactly that value, which is -7. Okay, now let's try another example. Let's say we're approaching x equals -4. All right. So here we have a jump discontinuity happening here. Let's see how that impacts the limits. Okay. So first question, what is the limit as x approaches -4 from the right direction? So if you're approaching -4 from the right direction, okay, what are you approaching? Are you oscillating towards that boundary? Is there a vertical asymptote there, or are you approaching a point defined or not? From the right-hand direction, you are approaching a point that is not defined, okay? So the limit is simply going to be the y-coordinate of that point that's not defined. And the y-coordinate is what? -2. So your right-hand limit is going to be -2. Question 2. What is the limit as x approaches -4 from the left? Okay, as you're approaching -4 from the left, we can see that we are approaching a point. Okay, -4 from the left is a point that's defined, but -4 from the right is a point that is not defined. Okay, so as you're approaching -4 from the left, you're approaching a point. So what is the y-coordinate there? As you can clearly see, the y-coordinate is -5. Okay, so our answer here is -5. All right, question 3. Now, what is the double-sided limit? What is the limit as x approaches 4 of the function? Now, remember, when there is no direction, that means that you're approaching from both sides. Now, since the left and right-hand limits are different, the double-sided limit does not exist. All right, finally, number 4. What is the value of the function when you're at x equals -4? This is just asking if this point is defined, what is the y-coordinate when x is -4? So if you take a look at -4, x is defined at this particular point here. So what is the y-coordinate at this point? It's going to be the same as the left-hand limit, okay? So the answer is going to be -5. All right, now let's take a look at another set of examples. How about we look at, let's see, how about look at x equals 2, okay? Take a look at the limit, directional limits, double-sided limits there, and also the value of the function at that point. So question number 1, what is the limit as x approaches, we're approaching, as x approaches +2 from the right side, okay? So what's the limit of f of x as x approaches +2 from the right? So we are approaching +2 from the right. Now, what is the case here? Is it a point? Is the function oscillating towards this boundary, or is there a vertical asymptote from that direction? If you look at the behavior of the function, as the function approaches +2 from the right, you notice that the function is tending towards infinity in the direction of that line. Okay, that's an asymptote for you. That's a vertical asymptote to be specific. So if you have a vertical asymptote as you're approaching the function in that direction, you ask yourself, is it going up or down? That will tell you if it's infinity or negative infinity. In this case, it's heading up, so our right-handed limit will be infinity. Okay? Now, what is the left-handed limit? The limit as x approaches 2 from the left of the function. The left-handed limit, as you're approaching 2 from the left, we're looking at this function right here. So you want to ask yourself, what are we approaching? A point, a vertical asymptote, or is it oscillating towards that point, towards that boundary? In this case, we have a point that is not defined. That doesn't matter. All we care about is what is the y-coordinate of that point, defined or not. In this case, the y-coordinate is +2. All right. So the left-handed limit is +2. Now, question number 3. What is the double-sided limit? The limit as x approaches 2 from both sides of the function. Since the left and right hand limits are different, in that case, the limit does not exist. Question 4, what is the output when the function has a value of 2? If you look at it from the right, you have an asymptote. On the left-hand side, you have an open circle. So neither of these portions include that x value that can be used in the determination of the output. So what does that mean? It means that the output at x equals 2 is undefined. Okay? So that's the result for what's happening around x equals 2. Okay, now let's do a concept check problem. We're going to be using an AP style question, multiple choice question, to test your understanding of what we just covered. Okay, so what you're going to do is you're going to, let's consider the question. It says, for which of the following does the limit of f of x as x approaches 4 exist? So you're going to pause the video, go ahead and solve the problem, and then when you're done, you hit play and check your answer with the explanation that I'm about to give. Okay, so let's go ahead and see if you got the answer to the problem correct. So for the first one, let's go ahead and find the double-sided limit. That is a composition or combination of two limits, the left and the right, okay? So for option I, the left-handed limit, limit as x approaches 4 of the function from the left. When you're approaching 4 from the left, let me write it better. When you're approaching 4 from the left, in this case, we are approaching a point that is on, well, the point is defined, but along the function is not defined, is defined somewhere else, okay? So as you're approaching this point, that's open, an open circle at that particular function, the y coordinate is basically what your limit is going to be, okay? So just since we have a point, just trace it to your y coordinate. So this is 1, 2, 3. So in that case, your left-handed limit is 3. Now, how about your right-handed limit? As the function approaches 4 from the right, you're still approaching that point that's not defined along the curve, but defined somewhere else. So you look at your y coordinate, which is the same as that of the x, which is 3 also. Now, since the left and right hand limit exists, are equal, sorry, what does that mean? It means that the limit exists. Okay, that's what we're checking for. Question number 2. Option 2, the limit as x approaches 4 of the function from the left-hand side is what? We're approaching a point again that's clearly undefined. It's actually not defined anywhere on this function, but we don't really care about that. What we're looking at is what's happening as the function itself is getting close to that point. We have a point that's not defined. The y coordinate of that point is your limit. So in this case, the y coordinate of this undefined point that the function is approaching is 2, 3, 4 is 4. Okay. All right. How about approaching from the right? The limit as x approaches 4 from the right of the function. You're still approaching the same undefined point. As long as it's a point, all we care about is the y coordinate of that point that the function is approaching. And it is also 4. Now, since these two are the same, guess what? The limit exists here. The double-sided limit is equal to these two. Okay? So let me just write down one notation for option 1 that implies that the double-sided limit is equal to 3. And then for option 2, this implies that the double-sided limit is equal to 4. Okay, let's take a look at the last one, option 3. Now, what happens as x approaches 4 from the left? What is the function approaching? Well, we have a jump discontinuity here, two distinct curves. From the left, we're approaching a point that's defined. So whenever you're approaching a point, you just determine the y coordinate of the point that you're approaching. In this case, the y coordinate is 4. So the left-handed limit is 4. How about the right-handed limit? Limit as x approaches 4 from the right of the function. As you're approaching 4 from the right, you have a point that's not defined, but since it is a point, we just determine the y-coordinate of that point, trace it out, so you can clearly see it is 2. Okay, as you're approaching this undefined point from the right, the function is approaching the value of 2, so your right-handed limit is 2. All right, so what does that mean? It means that the double-sided limit of the function does not exist because the left and the right hand limits are different. So option 3 is a fail. So the question says, which of the following does the limit as x approaches for the function exist? Options number 1 and 2, the correct answer is option letter B. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of limits, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel so you can get updates to other cool calc tutorials such as this. More clips can be found on math.serve.com under AP Calc. Thanks again for watching and have a wonderful day.